The moon is one of the most fascinating objects in our night sky. It hangs in our sky, a symbol of peace, mystery, and romance. For all of human history, it has been our constant companion. So, where did our moon really come from? And more importantly, where are we going with it? Hi, it's me. And if you want to learn something new about our universe every week, subscribe for more videos like this one. Part 1, The Violent Birth. About 4.5 billion years ago, the Earth wasn't the beautiful blue and green world we know today. Instead, it was just a hot, molten ball of rock. Well, first off, the moon rocks brought back by NASA. Apollo missions in the 1960s and 70s are remarkably similar in composition to the rocks found on Earth's crust. What use is an ancient moon rock? Well, this is where things get cool. You see, the moon isn't just a pretty space rock. It is a silent guardian, a protector that watches over our planet, allowing life to flourish. Did you know that without the moon, Earth would be a vastly different place? 1 degree doesn't sound like a lot, but even a small change would radically alter Earth's climate. For example, if Earth's tilt were to increase to 45 degrees, summers would be unbearably hot and winters would be frigid. Such wild changes would prevent complex life from evolving. We'd be stuck with simple bacteria. This is NASA's plan to return humans to the moon. There are still many mysteries of the moon that we need to solve. One of the most promising areas of research is finding water ice in the permanently shadowed craters of the moon's poles. This water could be used by future astronauts for drinking, breathing oxygen, and even as rocket fuel. And second, stepping stone to Mars. The moon is a perfect place to test new technologies and train astronauts for long-duration space travel. The moon is relatively close to Earth, taking just 3 days to reach. Let me know in the comments below, and don't forget to subscribe for more journeys through our incredible universe. It also has low gravity, which is a major challenge for long-duration space travel. And unlike Mars, the moon doesn't have an atmosphere, meaning that rockets can launch straight up without having to worry about air resistance. Artemis is also a big deal because it will be a truly international effort. Already, plans are underway to build lunar bases, perhaps using 3D printing to make buildings from moon dust. There are also plans to set up science outposts and maybe even start the first commercial activities on the moon. Imagine fueling your spaceship with helium-3, a fuel that could power future fusion reactors. Or imagine the scientific advantage of a radio telescope on the far side of the moon, shielded from all of Earth's radio noise. Along with NASA, there are partners from all over the world, including Canada, France, Germany, Japan, the UAE. Maybe you'll get the chance to visit one day. Maybe even stay in a lunar hotel and watch the sunrise over Earth. And yes, even from our biggest rival, China. Born in violence, the moon is the child of Earth and Theia, a reminder of the turbulent past of our solar system. It then became the silent guardian of our planet, stabilizing our climate and creating the tides that allowed life to flourish. And now it is calling to us once more, beckoning us to return and begin our cosmic future. Private companies like SpaceX are also contributing to the mission, making this a truly global effort. The moon keeps Earth's tilt at a nice, stable 23.5 degrees, allowing our planet to have mild seasons and be hospitable to life. In fact, we wouldn't be here at all. Without the moon, Earth would wobble wildly on its axis. The reason is that the moon's rotation period is exactly the same as its orbital period around the Earth. In other words, the moon rotates on its axis once every 27 days, the same amount of time it takes to orbit our planet. As a result, we can only see one side of the moon from Earth. The far side of the moon is not actually dark. It just receives equal amounts of sunlight and experiences regular days and nights. It's just really far away and difficult to observe. This is because the moon stabilizes our planet's tilt. And that might sound like a small thing, but it's actually huge. Right now, Earth's tilt is 23.5 degrees. That means that the North Pole isn't quite pointing at the center of the sun. This gives us seasons, but it also means that throughout the year, the northern and southern hemispheres take turns leaning towards the sun, giving each hemisphere more or less sunlight and creating the pattern of cold and warm seasons. In particular, the amount of aluminum, calcium, phosphorus, potassium, and sodium is nearly identical between lunar and terrestrial basalts. However, these rocks are also missing volatile elements such as water, which would have boiled away in the heat of the impact. Billions of years ago, the tides played a huge role in the origin of life itself. What role will it play in humanity's future? To answer that question, let's talk about the future of humanity. See, the shallow coastal waters where life first emerged were constantly being mixed and churned up by the tides. This created a primordial soup where organic molecules could be concentrated and become more complex, eventually forming the building blocks of life. The tides also acted as a giant thermostat, buffering the environment from the worst of the sun's radiation. Additionally, the moon has a tiny iron core, just 240 kilometers in diameter. This makes sense if Thea's dense core merged with Earth's core while the lighter rocky mantle formed the moon's crust. In contrast, Earth had started to acquire a metallic core. This was one of the most unimaginably powerful explosions in the history of the solar system. Every day, the moon orbits our planet, and its gravitational pull tugs on Earth's oceans, creating huge bulges of water on the side facing the moon and the side opposite the moon. Twice a year, these tidal bulges reach their peak, causing extra high tides called spring tides. When the sun, Earth, and moon are aligned, the gravitational pull of both the sun and the moon combine to cause even higher tides. During new and full moons, these highest tides are known as perihemal tides, and they happen about twice a year. During the other half of the year, the Earth and the moon are misaligned during spring tide. The gravitational pulls of the sun and the moon cancel each other out, resulting in lower than average tides known as neap tides. The combined energy released by this crash was over 10 trillion times greater than the atomic bomb dropped on Hiroshima. Theia was completely vaporized, and a large chunk of Earth's mantle was thrown into space. Theia's approach caused Earth to bulge at the equator, and as the two objects drew closer, their mutual gravitational attraction increased dramatically. With just weeks left before impact, Earth's gravity was ripping Theia apart, stretching it from a rounded shape into a long, thin shape like a giant space cigar. At that time, the solar system was a violent place. Planetoids, chunks of rock ranging from kilometers to hundreds of kilometers across, were flying around willy-nilly. Day and night, bits of rock rained apocalyptically down on Earth, and eventually this bombardment killed whatever life might have been forming in the oceans. Then slowly, over thousands of years, gravity began pulling this debris together. At first, it formed clumps of rock the size of houses. Then the clumps grew larger, eventually merging into planetoids the size of Texas. Slowly but surely, they all clumped together until, some 40 million years later, only one large body remained. It was the moon, and one of these planetoids, which we have named Theia, was on a collision course with Earth. Now, Theia was roughly the size of Mars, though it was a bit less massive because it was made entirely of rock. At last, the moment of impact. The two objects collided in a flash of fire and light. This debris formed a thick ring around the Earth, covering the planet in darkness for years. So that's the leading scientific theory anyway. But why do we think this? What's the evidence? Part 2, the silent guardian. I know what you're thinking. That's all very interesting, but what does it mean to us? Let's start with the most obvious. The moon creates our tides. While modern humans might find the tides predictable and even useful for navigation and recreation, They are truly a miracle of nature, but the moon does even more. In fact, the moon protects our planet in ways we didn't even know existed. However, without the moon, Earth would wobble so much that its tilt would change by several degrees every few thousand years. It's also worth mentioning that the moon is tidally locked to Earth. That means it always keeps the same face pointed towards us. Part 3, the next frontier. Now it's time to look forward. Where does the moon's story go from here? More specifically, let's talk about the Artemis program. But why go back to the moon? What's the point? Well, there are two big reasons. First, science. But beyond that, the moon also has huge potential as an economy. In the coming decades, the moon will become a place of industry, commerce, and even tourism. To conclude, let's recap the incredible journey of the moon. As we prepare to leave our footprints in its dust once more, we aren't just going to a new world. In a way, we're going home. What do you think will be the biggest discovery when we return to the moon?